Trapezium rule. Now, the trapezium rule is a way of finding an estimate for the area underneath a curve. Now, we've already looked to find the area underneath a curve using integration in Core 2. But now we're going to look at finding the area underneath a curve using the trapezium rule. Now, this is only going to give us an estimate for the value of the area underneath a curve. Now, this rule is given to you in your formula book, and I'm sure that in lessons your teacher will go through how to prove that the trapezium rule is what it is. You don't have to know that, but it is a useful thing to know to help you understand where the formula and the equation comes from. So, the first thing you need to know is what is the trapezium rule. So, it's the height divided by 2 in brackets of the first y value plus the last value plus 2 lots of all the other y values. And that is what is shown in our equation here. Now, what do all these bits relate to? Well, the h is the constant height of all the trapeziums. So all the trapeziums will be a constant height. So it could well be that they're going to be 0.5, it could be they're going to be 1, it could be they're going to be 2 the heights, but they're going to be constant for all the trapeziums. The y0 and yn value relate to our first x value that we're going to put in, so it would be x0, and our yn value relates to our xn, so the last value we're going to put in. So in our diagram here, y0, well, we'd have substituted x0 to get that value of y, and we'd substituted in xn to get this value of y. And all the other ones are all the ones in the middle. Now, there could be several more values for y in this section here. Okay, so let's apply this to a real life situation. So it says the rate of flow of water from a pipe is given by R equals 5 times 2 to the power of minus t in litres per minute, where t is the time in minutes. Find the volume of water which flows from the tank in 5 minutes using the trapezium rule with 5 strips. It mentions 5 strips, which means we're looking at using 5 trapeziums, which means we're actually going to have to find 6 different values for R. Now, our two variables in this question are R and T. Now, the R would probably usually represent our Y value, and our T would probably usually represent our X value. Now, we're asked to look in the first 5 minutes, so we're going to be looking at time in 0, 1, 2, 3, 4, and 5. Now, another thing you might want to do is change this the equation from R equals 5 times 2 to the power of minus t. Now, you should remember from Core 1 that t to the power of minus t is the same as saying 1 over 2 to the power of t. So, our equation actually is going to be R equals 5 over 2 to the power of t. You can use the equation in its current form. If you substitute all those values for t into our formula, you get the following values. You get 5, 2.5, 1.25, 0.625, 0.3125, and finally you get 0.1565. Now, what we're going to do is we're going to substitute each of these values into the trapezium rule, which is going to be in our case here, the area is going to be h over 2 for y0 plus ym. Well, our n in this situation is going to be 5 plus 2 lots of y1 plus y2 plus y3 plus y4. So, if we're substituting our values, so the height in this situation is 1, because the gap between all our t values is 1. So, our h value was 1, so 1 over 2, and our y0 is 5, our y5 is 0.15625, plus 2 lots of 2.5 plus 1.25 plus 0.625 plus 0.3125. Close the brackets, and you've got all our values substituted in. Your next thing is to tidy this all up a bit, and if you add together the 5 and the 15625, you get 5.1522625 plus, if you do the other bits and times, so you get 2 times 3.94. If you sort that bit out, you end up with half times 13.046875, and if you sort that out, your final answer is 6.52347375. Now that's a bit of a ridiculous answer. It is perfectly acceptable to round it. If it's asked you to do it to a certain amount in the question, that is fine. If not, to two decimal places is 6.52 square units. So that is using the trapezium rule to solve a question for finding the area underneath a curve. Possibly doing this question